Good day, everyone. Welcome back. I hope you're all doing great. We are looking in Math 10 Combined today at Lesson 2.1, Units of Area and Volume. This is still in Unit 1. Unit 1 covers all of the content in Chapter 1 and Chapter 2. So we're done with Chapter 1. If you are a West Country Outreach School student, then that means that you have a Chapter 1 evaluation that you have to complete. It's a Chapter 1 quiz and it's waiting for you at the school. So if you haven't completed that, you need to get in there and get it done and out of the way. We're looking today at working with units of area and volume, and we're going to be calculating what I would refer to as basic areas and basic volumes. I'll explain what basic means in just a few minutes, but we're going to be using different units. And we're going to be looking at how we can convert units of area to a different set of units of area. So for example, how many square feet are there in 12 square meters? That kind of question. And we already have some skills in our tool belt that deal with converting length units, but we haven't discovered how to do it for area yet, or volume. You will need your formula sheet today as well as a calculator. This lesson is all about examples. There are no notes, there are no warm-ups. We just dive right in. An art class is creating a mural mosaic, and they know that future art classes are going to have to contribute to the project in order to complete it. So far, I haven't really been told anything too interesting in terms of math, but now here it comes. Each person in the class makes a painting on a 15 centimeter by 15 centimeter panel, and there are 25 students in the class, and they're going to put the 25 panels together to form this mosaic. And we're asked to find the area of the entire mural. So I'm going to point out to you that the entire mural is this entire square. And this shape is a square because it's composed of 5 squares across and 5 squares tall. This is what I mean by a basic area. A basic area in my mind is a rectangle, something where you just take the length times the width. And there could be the odd person out there going, well, this isn't a rectangle, it's a square. Well, it's both. A square is a rectangle. It's just a special type of rectangle. So I need to know the length of this square and I need to know the width. Well, I know that this little piece of it is 15 centimeters. And I also know that there are 5 of these bits going all the way across. So this is also 15 centimeters. So is this. So is this. And so is this. So if I take 5 times 15 centimeters, I will get how wide this mural is. And I'm just writing this here because I have space to do so. So 5 times 15 centimeters gives me, and you can check it on your calculator, 75 centimeters, which means that this distance across the top is 75 centimeters. I'm not going to repeat the process. All of these little bits or pieces that are contributing to this mural are square, so we could do the same thing vertically to determine that this is also 75 centimeters. And what that means is now we have a length and a width that we can multiply. Let me explain. I mean, it might not need an explanation, but the reason why we converted those lengths and widths to centimeters, I guess we didn't really convert them. The reason why we're using centimeters here is because we are asked to find the area in square centimeters. A square centimeter is the same thing as writing a centimeter squared, and the only way you're going to get centimeters squared is by multiplying centimeters by centimeters. You can't get centimeters squared when you calculate area unless you're multiplying centimeters by centimeters. So that's why we're looking at using centimeters here. It's 75 centimeters times 75 centimeters. When we calculate this, you're actually doing two multiplications. You're multiplying 75 by 75, and you're also multiplying centimeters by centimeters. So let's start with the 75 by 75. You get 5,625. And the units will be centimeters times centimeters, which is centimeters squared. So that's the answer to the first question. The total area of this entire blue square would be 5,625 square centimeters. What about if we wanted to calculate the area of the mural in square meters? Well, let me just draw a square again. We know that it was 75 centimeters across. And 75 centimeters tall, but we are asked now to convert, well, not convert, what we are asked to calculate is the area, and we are asked to determine the area in square meters. Well, the only way you're going to get square meters is by multiplying meters by meters, right? That's the only way that you're going to get square meters. And that tells us that what we need to do is convert 75 centimeters to meters. In yesterday's lesson, I suggested to you that you don't always need to use a ratio, and in fact, using a ratio can be a time killer here. You should be able to just convert 75 centimeters to meters by moving the decimal 2 places to the left. So each of these dimensions are 0.75 meters. And that means if we multiply 0.75 meters by 0.75 meters, we will get the area in square meters. And it's 0.5625. And that's the answer to B. I want to point something out to you, that if you're converting centimeters to meters, you just move the decimal place 2 places to the left. But that doesn't work when you're converting square centimeters to square meters. And for that reason, whenever you're trying to convert units of area from one area unit to a different one, I don't want you using ratios or any of the rules we've learned so far. I'm going to show you a different method when the time comes. Let's take a look at the next example. A tile measures 1 foot by 1 foot. What is the area of the tile in square centimeters? So we're going to have to go to our formula sheet. If we want the area, which is length times width, in square centimeters, then we need to take this 1 foot and convert it to centimeters, and this 1 foot and convert it to centimeters. So we're back in chapter 1 now. Luckily, when you look at your formula sheet, at the bottom of your formula sheet, you will discover that there is, in fact, a statement. Let me move this over. There it is. Try that again. There is a statement near the bottom of the screen here in the center that says 1 foot equals 30.48 centimeters. In other words, everybody, we do not even need to use a ratio or anything. You're told 30.48 centimeters is a foot. So I can just write 30.48 centimeters. And now I can calculate the area. Since I'm multiplying centimeters by centimeters, I am going to get square centimeters. The numerical part of the answer is going to be what? 30.48 times 30.48 gives us. By the way, you could just take 30.48 and square it. You get 929.03. Well, 0.0304, but I'm just going to write 929.03 because that's all I have room for. Part B says the tiles are going to be used to cover a rectangular floor that measures 6 feet by 8 feet. So we're dealing again with a rectangle. It's 8 feet long and 6 feet wide. That's probably not drawn very well to scale. Just clean that up a bit. Yeah, maybe like that. So it's 8 feet across and 6 feet tall. This is 8 feet. This is 6 feet. To find the area in square feet, oh, that's child's play. You're just going to take the number of feet across and multiply by the number of feet across and get 48 square feet. Now, what if I asked you to determine the area in square centimeters? Well, you could convert the 8 feet to centimeters and the 6 feet to centimeters. You know that 1 foot is 30.48 centimeters. So if you set up a ratio or you use a little bit of common sense, you will discover that 8 feet in centimeters can be found by taking 8 times 30.48. Eight times 30.48 gives you that many centimeters across, and 6 feet times 30.48 gives you that many centimeters. That can't be right. 6 times 30.48 gives you that many centimeters tall. So 243.84. By 182.88. And if you take those centimeters and multiply them, you're going to get the area in square centimeters. I'm not going to write down those numbers again. They're sitting right there on the screen. So I'm going to take the 243.84 and multiply by the 182.88, and I get 44,593. $44,593.5, we'll say, and that would be square centimeters. I would like to point something out to you that you could have taken a little bit of a shortcut. When we go back and look at the area of one of these tiles, it was 929. I'll remind you what it was precisely. It was 929.0304 square centimeters, and that was 1 square foot. This is 1 square foot. This tile you're looking at is a square foot. It's 1 foot times 1 foot. We'd already figured out that it was 48 square feet So if it would have occurred to you, if the number on my calculator is 1 square foot, if I just multiply that by 48, I get the same answer that I got when I did it the other way. If I want to figure out what it is in square meters, well, then I have to convert the feet to meters or the centimeters to meters. I'm going to convert the feet to meters because I think that there are less decimals involved here. So I'm going to go to my formula sheet. When I look at my formula sheet, I have 1 foot equals 0.3048 meters. 1 foot is actually equal to 30.48 centimeters, but that's 0.3048 meters. So I can use that ratio to take 8 feet and find out how many meters it is. So 0.3048 meters over 1 foot equals X meters over 8 feet. What I discover is when I cross multiply, I'm going to end up multiplying this number times this number. So if I take 0.3048 and multiply by 8, this is the length in meters. Sorry, this is the length in meters. 2.4384 meters. If I repeat the process, and you'll have to look at the screen here, I'm not trying to confuse you, but I think we can shave a little bit of time off of this. If we repeat the process but use 6 feet, then we're going to be multiplying 6 by that number. We're going to be multiplying the 6 by the 0.3048. 6 times 0.3048 gives me this for the other dimension of this rectangular shape. And this will also be in meters. So now you simply have to multiply the length by the width, and that will give us an answer. 2.4384 multiplied by 1.8288. Double check my entries. 1.8288. Missed one over here too, 4384. So 2.4384 times 1.8288 gives me about I'll just round it and say 4.5 square meters. And it's approximate because I'm rounding, but we can't carry all the decimals all the time. I don't want to write down a whole bunch of decimals just because they're there. I think it's okay to round it. So the answer to the third part of part B is 4.5 square meters. If we go back and just look at this briefly, 48 square feet, 44,593 square centimeters, and 4.5 square meters are all the same area. So we have a rectangular field measuring 1.5 kilometers by 1.0 kilometers. What's the area in square meters? Well, it's length times width. This is how we find the area. But we want it in square meters, so we're going to have to use the length in meters and the width in meters to find the area in square meters. Going from 1.5 kilometers to 1,500 meters, and from 1 kilometer to 1,000 meters is elementary school math. You move the decimal place 3 places to the right. So now I multiply them. You can use your calculator if you like, but you're going to get the following number. You're going to get 1,500,000 square meters. B, how do we find the area in square miles? Well, we have to use the piece of information on our formula sheet that says 1 mile is 1.609 kilometers to convert the 1.5 kilometers to miles and the 1.0 kilometers to miles, so that we can take whatever we get for the length in miles and multiply by whatever we get for the width in miles. So when we multiply these two things, that will be the area. Ratio time again, 1 mile over 1.609 kilometers equals X miles over 1.5 kilometers. We can do a cross multiplication there. It's going to be 1.5 times 1 divided by 1.609. Gives me a little bit less than a mile, 0.932256. Repeat the process, but this time what we're going to use is 1.0 kilometers. So 1 times 1 divided by 1.609. Gives me 0.6215. Miles, and we need to multiply those together. We need to take 0.932 whatever miles times 0.6215 whatever miles. And if you have a graphing calculator, which you're going to need in this course, it's not even a recommendation, it's a requirement. If you just focus your attention at my calculator screen, I don't need to write down any of those numbers. What I can do is I can just say times, and it says answer times, and that means that answer is 0.6215040398. It has all those digits. I want to multiply by that 0.9322. I can use the up arrow to go up and highlight that and hit enter, and it will bring it down. There's no need for me to write down a bunch of numbers. What we're getting is about 0.58 square miles. And I didn't say it, but I'll say it now. In any of our answers for area or volume, which is coming up, we need to write units everywhere there are units. Now that takes us to how do we convert one set of area units to another. So we have some shape, and you don't know what the shape is. Its area is 2,500 square centimeters. What is that in square inches? So there is a complicated way to do this, which I am not even going to show you. My experience has been that when I explain the traditional approach to students, Some students get it, but most students don't, and they're not very successful at it. So what I'm going to do is I'm going to tell you a different way to do it. I'm going to say that you have the power to make any rectangle you want that will give you that area. So all you have to do is come up with two numbers that multiply to give 2,500. Well, 100 times 250 does it. If this is 250, or 100 times 25, pardon me, if this is 25 and this is 100, just confirm to yourself, either with a calculator or in your head, that 100 centimeters times 25 centimeters will give you 2,500 centimeters. Definitely it will. If you want to be creative, and I'm not saying you have to, but you could go, I think 50 times 50 does it. I'm pretty sure 50 multiplied by 50 does it. $50 centimeters multiplied by 50 centimeters. That does it. Okay, so let's say it's 100 centimeters by 25 centimeters. You have the ability to convert 100 centimeters to inches and 25 centimeters to inches, because you know that 1 inch is 2.54 centimeters. So x inches over 100 centimeters will allow you to find out how many inches that is. You cross multiply, it will be 100 times 1 divided by 2.54. $39.37 inches. And you can do the same thing with the 25 centimeters. I'll erase the 100 and put 25 in here. Grab your calculator. It's going to be 25 times 1 divided by 2.54, which is 9.84 inches. 9.84 inches. And then to find the area, you're going to multiply the inches by the inches. So I'm going to take that and multiply by this, and this is the answer I get. I'm just going to pull it up and pop it on the screen here. You get 387.50075. All right, so what if you would have changed it to 50 centimeters by 50 centimeters? Well, that would mean that you would put 50 centimeters down here in your ratio. And you would have gotten 50 times 1 divided by 2.54. You would have gotten 19.685 inches. For both of these. Well, what happens if you take that answer times itself? You get 387.500775. You get the same thing. And just trust me, have faith in what I'm telling you. This is the best way to do it. Create a shape that has dimensions that give you that area. Then change the dimensions to the new units and find the new area. Well, it's not a new area, but find the area with the new units. So this is our answer. We still have volume to go, and volume is not going to take very long. When you're talking about something that is box-shaped, and that's all I will say at this point in time. You have something that is box-shaped. Like you get a delivery from Amazon and it's in what you might call a rectangular box. The volume is length times width times height. And because of that, you're going to get units cubed, because we're about to take a length that's in meters, a width that's in meters, and a height that's in meters, and multiply them. And when you multiply meters by meters by meters, you get cubic meters. We don't need any conversions here for this first part of this question, because all of the dimensions are given in meters. It's 3.5 meters long. It's 2.3 meters wide, and it's 2.2 meters tall. The order in which you label these things doesn't matter. You could say it's 2.2 long, 3.5 wide, and 2.3 tall if you tipped it on its side. So we're multiplying those three dimensions, and now we see what we get. .5 multiplied by 2.3 multiplied by 2.2 gives me 17.71. Just double check my entries. Looks okay. Cubic meters. A cubic meter, if you can imagine the length of a meter, a cubic meter of volume or a cubic meter of space is a box that is 1 meter wide by 1 meter tall by 1 meter deep. Now, what if we are asked to do this in cubic feet? Well, then what we want to do is we want to change that 3.5 meters to feet. We want to change the 2.3 meters to feet. And we want to change the 2.2 meters to feet. And then take the length in feet times the width in feet times the height in feet. So how do we do that? Well, we look at our formula sheet. What are we told about meters and feet? We're back to that one that's still highlighted on my screen. 1 foot is 0.3048 meters. I know it doesn't say that, but if we move the decimal 2 to the left, 1 foot is 0.3048 meters. So we can put 1 foot over 0.3048 meters equals x feet over 3.5 meters. And I want you to notice that when you cross multiply, you're going to end up taking 3.5 times 1 divided by 0.3048. So when we do the same thing with the 2.3, we're just going to change the 3.5 in our calculation to 2.3. It's not a big deal. And you know, maybe what I'm getting at is it shouldn't be taking you very long to do conversions at this stage of the game. So 3.5 divided by 0.3048, that is the length. If we use 2.3 instead, it will be 2.3 divided by 0.3048. And if we use 2.2, it will be 2.2 divided by 0.3048. So about 11.48 feet by 7.55 feet by 7.22 feet. So you have to multiply those numbers together. I'm not going to worry about exact values here. We're going to take 11.4829 and multiply by 7.5459 and multiply by 7.2178. I'll just step back and look at those numbers. 11.4829, 7.5459, 7.2178 looks good. Going up and grabbing those numbers is more complicated when there's three, so I'd rather not get into it. We get for a volume approximately 625 cubic feet. I think we have one more question to go. Oh, cubic yards. Well, you know what? I'm gonna skip that one. What you can do is convert 3.5 to yards, 2.3 meters to yards, 2.2 meters to yards, and then multiply the yards by the yards by the yards. I think you're getting the drift of this, that when you calculate a volume or an area in a new set of units, you convert all of the dimensions to those units, and then you do the calculation. And we're also going to skip number 6. I want to cut to the chase here and talk about number 7. You have an engine which has a volume of 5,200 cubic centimeters. 5,200 cubic centimeters. Now, you and I know that an engine is not box-shaped, but we can take this volume and represent it as a length times a width times a height, and it's going to give us 5,200 cubic centimeters. So what we're going to do is make a box out of this volume in our head using three numbers, any three numbers that multiply to give 5,200. Well, there's 100 in there, right? 52 could be a length. And then there's 100. Well, let's break the 100 into 10 centimeters and 10 centimeters. This would give us 5,200 cubic centimeters. So what we're going to do is convert those three made up length, width, and heights, convert them all to inches, and then multiply it, and we will get cubic inches. And believe me, this is going to work even if you changed it to 1 centimeter by 1 centimeter by 5,200 centimeters, and converted this to inches, this to inches, and this to inches. It doesn't matter which one you do. So 1 inch is 2.54 centimeters equals x inches over 52. When I cross multiply to solve there, I'm going to take 52 times 1 and then divide by 2.54. There's zero reason why we want to go times 1. It's not going to change things. So in inches, that's 20.47 inches. Then we're going to go 10 and 10. All that means is in our ratio, it's not going to be 52, but it's going to be 10. And what that means is in my calculation, I'm going to take 10 divided by 2.54. And get 3.937. And we kind of lucked out a little bit because that's 3.937 for both. So we multiply those all together. I'm going to take this number, I'm just going to square it because I'm multiplying it by itself. And then I'm going to multiply by this number, and what I get is about 317 cubic inches. And that's the lesson. It's kind of a tedious lesson because of all of the conversions, but when you break it down, the bottom line is change all of the dimensions to the new units before you do any calculations. That's it. In the meantime and in between time, there are some practice problems on page 61 of your textbook, and there are also some problems attached to your unit handout on page 13. Let me just check. On page 13. No, on page 14, there's a couple of extra ones there. Once again, a reminder, if you're a West Country Outreach student, then you need to write your Chapter 1 evaluation and get it done and out of the way. All right, we'll talk to you later. Take care.